This grey slab of concrete has spent 40 years doing the most unglamorous job in the modern world. It holds back sewage, and yet, on a cold morning in Delft, it has started very quietly to breathe. Concrete built the century we live in. It is also one of the largest single sources of carbon on Earth. So here is the question this small Dutch project is chasing. What if the concrete we already poured could be made to pull carbon back out of the air, instead of putting more in? The reflex answer, when a structure ages, is to knock it down and build something greener. But demolition is a carbon crime scene. Tearing down a reinforced tank and pouring a new one can emit more CO2 than the old building would in a decade of running. So the team behind the Biolighthouse made a different bet. Keep the concrete, keep every ton of embodied carbon already locked inside it, and bolt life onto its walls. Those walls are now wrapped in slim vertical tubes, glowing a deep emerald green. Inside them, water and microscopic algae circulate in a slow, endless loop. This is a photobioreactor, a living machine that runs on sunlight and waste. And here is the clever part. The plant is already swimming in exactly what algae crave. Wastewater arrives loaded with dissolved CO2 and with nitrogen, the nutrient that in excess chokes rivers and coastlines. To the algae, that is not pollution. That is a feast. The algae drink the carbon and strip out the nitrogen as they grow, cleaning the water on their way to doing it. One process, two problems solved. The building's own emissions and the region's nutrient runoff, feeding the same green bloom. Every few days, the algae are harvested, thickened into a dense green paste, then heated and pressed until they surrender an oily liquid. That liquid is bio-crude, a raw, plant-grown fuel wrung from sewage and captured carbon. The targets are deliberately modest and deliberately honest. Over 3 years, a 20% cut in the building's operational carbon footprint and a 10% reduction in the nitrogen this site sends into the local water. Not a miracle, a measurable dent, because algae have broken hearts before. For 20 years, algae fuel was the future that never arrived. The ponds got contaminated, the pumps ate more energy than the fuel returned, and the economics collapsed at scale. The Biolighthouse quietly sidesteps each of those traps. The feedstock is free, it's the plant's own waste stream. The structure is free, it already exists. And the reactor runs alongside a working treatment plant near TU Delft, where the researchers can measure every input and every gram of output. That is the whole thesis, standing on one modest site. Don't demolish the industrial past. Colonize it. Turn a liability of grey concrete into a distributed network of small living carbon sinks. And Europe has tens of thousands of these structures. Aging wastewater plants, disused industrial tanks, concrete already paid for in carbon. If even a fraction wore this green skin, the continent's forgotten infrastructure could start doing quiet, cumulative work for the climate. It won't save the world on its own. 20% is not 100, but that is rather the point. Real solutions are additive, unglamorous, and buildable now. A concrete relic in Delft, learning to breathe. If you want the real numbers, the carbon accounting, the nitrogen data, and how a retrofit like this could work on a structure near you, the full breakdown is in the link below. It's where this story keeps going.